We'll start with a nice, simple element. Hydrogen. Atomic number 1 has 1 electron. Well, it should be easy to figure out where that electron is. If we go back to our chart, we see that the lowest amount of energy would be the first principal energy level in the S sublevel. So we're going to designate that this way. We'll use a capital 1 for the first principal energy level, a little s for the sublevel, and we're going to use a superscript just to indicate how many electrons are there. So we've got our principal energy level, or principal quantum number. We have our sublevel, or orbital. And we have the total number of electrons that happen to be in that sublevel, or principal energy level. So there's a lot of information about the address of that electron. Let's see how that translates to the Bohr model, because that's something you're all familiar with. Boom. 1 electron in the first principal energy level, and there it is. Let's go to something more complicated. Helium. So do a little erasing here. Two electrons. I wonder where they are. We can probably imagine that they are in the first principal energy level again. And you can hold up to 2 in every sublevel, so we're not at 2 yet, or we just got to 2. So that's probably where they are. So again, we'll use our 1 for the principal energy level, the S for the sublevel, and now there are 2 there. And we might say that's full. Okay? Lithium, 3 electrons. I wonder where they are. Well, you can probably see a pattern starting to develop here. The first 2 are going to be in the first principal energy level, S orbital, but that's full, and we have 1 more electron to account for. I wonder where that one is. Let's go back to our chart for a second. If this one is full, what's next? Second principal energy level, and the lowest level orbital is an S. So we'll write a 2 for the principal energy level, S for the orbital, and there's only 1 electron there. Note, 2 plus 1 is 3. I'll do beryllium, and you see if you can come up with it as I go here. I'm not going to say anything. Beryllium has 4 electrons. 2 of them are in the first principal energy level, S sublevel, and 2 of them are in the second principal energy level, S sublevel. One more. Now that that's full, let's see what happens. We go to boron. And again, electrons are in the first principal energy level, the lowest possible energy level. The next two are in the next lowest possible energy level. That's 4 electrons. And what about the fifth one? Let's go back to our chart. Now that this is full, we need to go to the next highest energy, which is the p orbital. There's only 1 electron there. Now I'm going to skip, but you're going to need to leave some space because you're going to be doing elements 1 through 36, so you can leave some space. I'm going to skip all the way to neon so you can see how to notate this when you get more electrons than 2. But neon has got 10 electrons, and it's going to need to have 2 of them in the first principal energy level, 2 in the second principal energy level, S sublevel, and a total of 6 in those p levels. So I can write 2p6, and that accounts for all 10 electrons. So you have enough information to write all of the electron configurations for elements 1 through 36. There's only one more piece of information you need because there's a little bit of a glitch here. Question is, when you get to here, which of these has a lower energy? That's not right. When you get to here, which of these has a lower energy? You would think 4 has a lower energy because it's an S. And some of you might think 3 has a lower energy, so this one has a lower energy. It's kind of a toss-up, but as it turns out, 4S has lower energy than 3D. So when you get to that point in your configurations, as you're doing them 1 through 36, as soon as you finish filling up the 3p level, you're going to need to fill electrons into the 4s level first, and then come back and fill into the 3d level. When you get to 4p6, you're done. Hopefully you'll get to 4p6, and that'll be krypton. Let's look at one more thing. We filled in the electron for hydrogen, and if we were to fill in the electron for helium, right? There's 2 electrons in the first principal energy level, S orbital. As we continue, lithium, that's full, so lithium has to have 1 electron in the second principal energy level. Okay. Beryllium, four electrons total, 2 of them in the S orbital of the second principal energy level. Then we went to boron with 5. With 1 electron in the p orbital. Then I skipped all the way down, I think, to neon. which means the electrons now need to fill in p orbitals. And if you take note of how I'm filling them in, this will come in handy later on. And now we've filled up the second principal energy level. Okay. So hopefully you can see how all of these notes, the addresses of the electrons, translates into where they actually are in the atom. And it's far too complicated to show where they would be in here. Which is why we use this notation instead. All right, good luck. Writing the electron configurations for atomic number. (1 through 36).